There's quite clearly a trend going on here. We can see that as the number of hours of sunshine increases, the maximum temperature, that's also increasing. And it's kind of rising in its pattern here. And most of the data is quite close together. If we were to draw a line of best fit straight through the middle of this data, we can see that most of the points are really close to it. None of them are really that far apart from one of them. And this is our outlier. It's quite far out from the other ones. It's just not really part of that data. It signifies that it's a anomalous result, and maybe there's some mistake with recording, or it was just some freak accident. What we see here is positive correlation, because as the sunshine is increasing, the maximum temperature is also increasing. And that's positive when both of the variables are increasing together. If one was increasing while the other one was decreasing, then we can call that negative correlation. It'd be a negative gradient. Here we have a positive gradient. To estimate the number of hours of sunshine in the day, this is only going to be an estimate because, as we saw from the graph earlier, there is a bit of scatter. They're not all following a direct straight line. And also, we might not have any data for 16.4, so we're going to have to compare it to data points which are close by. But we can use the line of best fit. So if I draw a line of best fit going right through the data, now it doesn't have to go for the origin. I don't have to force it through there. And bear in mind, that's a false origin as well, so that's definitely means that it doesn't have to go through there. Now 16.4, you might be tempted to just count 4 boxes upwards from 16.4, but then this would make this 16.5, and clearly 16.5 can't be halfway between 16 and 18. That would make this 70, not 80. So we have a different scale going up here. Now in order to determine what this scale is, we have a difference of 2 here. We've gone up a jump of 2, and we've done that over 10 boxes. So if I divide that jump of 2 across the 10 boxes, that gives me 0.2. That tells me that each individual box going up is a value of 0.2. So 16.4 is going to be 2 boxes above 16. Let's just see if this trend works. So 16.6, 16.8, 17. Yes, that does work, and that's halfway between both. So next we want to draw a line from 16.4 to our line of best fit, and then down to the x-axis. Now again, we need to be careful of the scale here. That's not 12.9. This is a jump of 2 across 10 again, so it's going up in 0.2. That makes this 12.8. Now it does vary on your line of best fit, because obviously this was just gauged by eye. When I drew this line of best fit, I could have drawn it slightly differently. I could have adjusted this gradient slightly. I could have had it maybe going down here instead, and you're going to get a slightly different result if you did that. You can see if it goes up to 13 if I did that. And of course you could get lower as well, so if I was to adjust my gradient down that way a bit, then I'm going to get more of a value, maybe down more towards the 12. Clearly the Weatherman is correct, because we deduced right at the start that there is a positive correlation between both of these variables, and we can just see as you increase the temperature, the data supporting that, the sunshine is also increasing.